Okay, so last time we got a chance to practice some naming of acids. We're not going to spend a lot of time with naming bases because they're basically all the same. There's no difference in their functions. So today we're going to be playing around with what acids and bases do. In other words, what do acids do? You'd be surprised. And we're only going to worry about one thing. Acids produce hydrogen when they dissolve. And that's all we're really worried about. Okay? So, in chapter 13, we spent a lot of time practicing our dissociation equations. It works exact same way with acids. So, for example, if we have our buddy hydrochloric acid, which you're pretty good at naming because you spent some time practicing, right? Well, just like every ionic compound, hydrochloric acid dissociates right down the middle. And that's all it does. That's all we're worried about. It doesn't matter if it's a binary acid or if it is an oxyacid, because remember that this is a polyatomic ion, and it's going to split it right down the middle. And the only time it ever gets weird is if we have acids that have more than one H+, because you know there are some that do. Here is our buddy sulfuric acid. Okay, you learned how to name that, and that is a polyatomic ion, sulfate, split right down the middle. Well, there's two hydrogens in this. So we'll get dissociation that looks like this. Remember, that's a polyatomic ion. Okay? You know what these look like because you've seen this list many times. Okay? Finally, if we have something like this is our buddy phosphoric acid. That's a polyatomic ion, so we don't need to mess with it. Okay? So when it dissociates, right down the middle. And that means that we'll get our phosphate, but we're also going to get 3 H pluses. All right? So that's all acids do. They produce hydrogen. What do bases do? And there's one answer. They produce hydroxide, which is a polyatomic ion that looks like this. In fact, all the bases that we'll be working with have it right there, not only in the name, but in the formula. So this is something called sodium hydroxide. It is a base, and what it does in solution is dissociate into sodium and hydroxide, and that's all we need to worry about. Okay? Sometimes we'll have bases that have more than one hydroxide. This is called barium hydroxide. Okay? Barium hydroxide, it's a base, it's an ionic compound, and that looks like this. You have two OHs, and so it dissociates into two hydroxides. Okay? Last one we might run into is something that looks like this. This is aluminum hydroxide. And aluminum hydroxide has got 3 of these. It dissociates right down the middle. Aluminum has a charge of 3 plus, right? You know that because here's your list of ions. There it is. Okay, aluminum with a charge of 3 plus, and not 1, not 2, but 3 hydroxides. Okay? Now, one of you asked me, what happens when we mix them? In other words, what happens when we combine acids and bases? Okay, it's a very simple process, and it's called neutralization. Okay, let's see what we're talking about here. Let's say we take a couple of really simple acids, HCl and NaOH. Okay, hydrochloric acid and sodium hydroxide, really simple. And what is going to happen when they combine? Well, look at this. You've got two ionic compounds that dissociate right down the middle. You guys remember what a double displacement reaction looks like? Where AX combines with BY to make BX and AY. And the order doesn't really matter. So here is our B, and here is our X, and that means that our BX is going to look like this, sodium and chlorine, which of course you know of as sodium chloride. A is H. Y is OH. What do you get when you combine H plus and OH minus? You get HOH. Do you guys know another name for something that's got one oxygen and two hydrogens? Okay? That's it. That's called a neutralization reaction. So, the products of a neutralization reaction between an acid and a base are always water and a salt. Not just salt, not just sodium chloride salt, but a salt, an ionic compound, a compound that contains a positive ion and a negative ion. And that's all it is. All right? Let's try one more, and then I think you'll get the hang of it. So let's take an acid that looks like this. This is called carbonic acid. Let me write that a little bit more neatly. And let's combine it with a base, strontium hydroxide. Okay? All right. This is a double displacement reaction. AX combines with BY. Our products don't even necessarily have to be in any particular order. Will be BX and AY. Now, if I was going to ask you to balance this and all that crazy stuff, I'll show you how to do that, but I'm not really all that interested in that part. What I'm interested in is, can you identify what our products are? And we'll start with the easy one, A and Y. That's A and that's Y. It doesn't matter that we've got two hydrogens and two hydroxides. It doesn't matter. Because if we were going to do that, 2H plus combines with 2OH minus to make 2HOH, 2H2O. Easy peasy. Here is our B, that's our strontium. And if you were wondering, strontium's right up here. It's got a charge of 2 plus. And our X is this guy, CO3. It's a polyatomic ion called carbonate. He's right here. He's got a charge of minus 2. Well, what happens when you drop and swap two charges that are the same? They just disappear. So what are the products of this neutralization reaction between H2S3O3 and SrOH2, strontium carbonate, and 2 waters? All I'm looking for is, can you tell me this and can you tell me that? Okay? So take it for a spin.